Hi, we are going to be looking at the derivatives of logarithmic functions. So our derivative of the natural logarithm of x is just going to be 1 over x. Our derivative of log base a of x is 1 over x times 1 over the natural log of a. The derivative of the natural logarithm of a function of x is equal to 1 over that function of x times the derivative of that function. And if we have the derivative of log base a of a function of x, that's 1 over the function of x times the derivative of that function times 1 over the natural logarithm of a. So we're going to look at coming up with a derivative for y equals the natural logarithm of the absolute value of f of x and come up with a rule based off of this. So because we're looking at the absolute value of x, or a function of x, we're actually going to split this into two things. So we're going to look at if our f of x is greater than 0, in which case our absolute value does nothing. And we're also going to be looking at if f of x is less than 0, in which case we'll have a negative value, that the absolute value will change. So if f of x is greater than 0, then y equals the natural logarithm of the absolute value of f of x is just going to equal the natural logarithm of f of x, which the derivative of that would just be 1 over f of x times d dx of f of x. So that'd be 1 over f of x equals, or sorry, times f prime of x. And we can rewrite this as y prime is equal to f prime of x over f of x. Now, if f of x is less than 0, our absolute value is essentially going to be multiplying f of x by -1. So that would make y equals the natural logarithm of absolute value of f of x the same as the natural logarithm of negative of f of x. Which means y prime would be 1 over negative f of x times d dx of negative f of x. So you'd have y prime equals 1 over negative f of x times negative of f prime of x. Now you'll notice our negatives will cancel out, so that gives us y prime is equal to f prime of x over f of x. So you'll note we actually get the exact same thing for both sides. So we can say, therefore, our derivative of the natural logarithm of the absolute value of a function is equal to 1 over f of x times f prime of x, or another way of writing that, f prime of x over f of x. Okay, so look at some examples. So we've got y equals the natural logarithm of sine x. So we're going to have to take well, uh, derivative of our natural logarithm. Then we'll have to use our chain rule for sine x. So we end up with y prime is equal to 1 over sine x times the derivative of sine x. So that gives us y prime equals 1 over sine x times cos x, which would be y prime is cos x over sine x, which means we have cotangent of x. Next, we have y equals the logarithm of x cubed minus 2. Now, because we don't have a base listed, we know this is a common logarithm, so base 10. And the absolute value here, as we learned a couple of slides ago, isn't going to actually impact our overall answer. So we have y prime is equal to the derivative of the logarithm, which will be 1 over x cubed minus 2 times the derivative of x cubed minus 2 times 1 over the natural logarithm of the base of this one. So this one was base 10. So that gives us y prime is equal to, we can combine these right away. So 1 over x cubed minus 2 times the natural logarithm of 10 times our derivative of x cubed minus 2 would be 3x squared. I'd move a 3x squared into our numerator, so we've got y prime equals 3x squared over x cubed minus 2 times the natural logarithm of 10. Okay, next example, we have the natural logarithm of the natural logarithm of x cubed plus cos x. So we're going to have to deal with the chain rule a fair amount with this. So we'll start with our outer logarithm. So we've got y prime is equal to 1 over what's inside of it. So the natural logarithm of x cubed plus cos x times the derivative of this inner logarithm. So natural logarithm of x cubed plus cos x. So that'd be y prime equals 1 over our natural logarithm of x cubed plus cos x times 1 over x cubed plus cos x times our derivative of x cubed plus cos x. Okay, so continuing on, we'll take our derivative of this. We've got y prime equals, we might as well combine these as a single fraction. So we've got 1 over x cubed plus cos x times the natural logarithm of x cubed plus cos x times the derivative of this, which is going to be 3x squared minus sine x. So we've got y prime is equal to 3x squared minus sine x all over x cubed plus cos x times the natural logarithm of x cubed plus cos x. Okay, next example, we have one where we're going to have to utilize our quotient law. We've got y equals the natural logarithm of x over x squared. So this would be the same as saying y prime is equal to d dx of our natural logarithm of x times x squared plus our natural logarithm of x times our derivative of x squared all over x squared squared. So that gives us y prime is equal to a derivative of natural logarithm of x, which is 1 over x, times x squared, plus the natural logarithm of x times 2x all over x to the power of 4. So that gives us y prime is equal to x plus 2x natural logarithm of x over x to the power of 4. Now we can divide an x out of all the terms. So we've got y prime is equal to 1 plus 2 times the natural logarithm of x over x cubed. Okay, for our next example, we have find the equation of the tangent line to the curve y equals the natural logarithm of x cubed at x equals e. So first thing I'd probably do is find the y value when we have this. So we're going to look for f of e. So that would be when we've got natural logarithm of e cubed. Natural logarithm of e would just be 1. So we've got 1 cubed. So that's just going to be 1. So we know that e comma 1 is our tangent point. Now we'll find our derivative of our equation to get our slope equation. So we have this exponent we have to deal with first. So 3 times the natural logarithm of x squared times d dx of the natural logarithm of x. That gives us y prime is equal to 3 times the natural logarithm of x squared times 1 over x. So we've got y prime is equal to 3 times the natural logarithm of x squared over x. So now we want to find what the slope is at an x value of e. So I'll say f prime of e is equal to 3 times the natural logarithm of e squared over e. So this is just going to simplify to 3 over e. So when we write our equation of the form y minus y1 equals m times x minus x1. We have y minus 1 equals 3 over e times x minus e. Okay, next example, we want to differentiate the natural logarithm of the square root of x to the power 4 plus 2x times e to the 3 to the power of x times secant squared x all over natural logarithm of x. Now, if this looks very complicated to take our derivative of right of way, however, what we can do is we can use our log laws to break this up. So this is the same as saying y is equal to the natural logarithm of the square root of x to the 4 plus 2x plus the natural logarithm of e to 3x plus the natural logarithm of secant squared x minus the natural logarithm of the natural logarithm of x. Now, a square root is the same as saying to power 1/2, and we can use our power law to move that in front. So this is the same as saying y equals 1/2 times the natural logarithm of x to the power 4 plus 2x. Now, our natural logarithm of e to 3x would just equal 3x. We've got plus 3x. We can use our exponent or power law to bring the 2 in front. So we've got plus 2 times the natural logarithm of secant x. And then we've got minus the natural logarithm of the natural logarithm of x. And now we'll take this form and take our derivative. So we've got y prime is equal to 1/2 times the derivative of the natural logarithm of s, which would be just 1 over x to the power 4 plus 2x times d dx of x to the power 4 plus 2x plus the derivative of 3x, so that's just going to be plus 3 plus 2 times the derivative of the natural logarithm of secant x, so that'd be 1 over secant x times d dx of secant x minus the derivative of our natural logarithm of the natural logarithm of x, which would be 1 over the natural logarithm of x, and then times the derivative of the natural logarithm of x. So this becomes y prime is equal to 1/2 times 1 over x to the power 4 plus 2x times 4x cubed plus 2 plus 3 plus 2 over secant x times the derivative of secant x, which is secant x tan x, minus 1 over the natural logarithm of x times the derivative of the natural logarithm of x, which is 1 over x. So we've got y prime is equal to 4x cubed plus 2 over 2 times x to the power of 4 plus 2x plus 3, and then we can see our secants are going to cancel out. So plus 2 tan x minus 1 over x natural logarithm of x. Now we can see we can reduce this term here. So we've got y prime is equal to 2x cubed plus 1 over x to the 4 plus 2x plus 3 plus 2 tan x minus 1 over x natural log of x. So this would be as simplified as we can get. Okay, next we're going to talk about logarithmic differentiation. So if a function is in b to b form or is complex, we want to use log differentiation. So first thing is we're going to take the natural log of both sides, then use log loss to expand our equation. We'll then differentiate both sides in terms of x, and then solve for y prime or dy dx. So we'll do a couple examples of this. So for example, we want to differentiate y equals x to the power of x. So our first step is we're going to take the natural log of both sides. So we have the natural log of y equals the natural logarithm of x to the power of x. So we'll use our power law now. So we know we've got the natural log of y is equal to x times the natural logarithm of x. Now we're going to take the derivative of both sides. So we've got d dx of our natural logarithm of y equals d dx of x times the natural logarithm of x. Now our derivative of our natural logarithm of y is just going to be 1 over y times the derivative of y, which is y prime. And that's going to equal, on this side we have two things multiplied, so we have to use our product law. So d dx of x times the natural logarithm of x plus x times d dx of the natural logarithm of x. So I've got y prime over y equals our natural logarithm of x plus x times 1 over x. So that gives us y prime over y is equal to natural logarithm of x plus 1. multiply both sides by y, and we get y prime is equal to y times the natural logarithm of x plus 1. And then because we know what y is, we can substitute that equation back in. So we have y prime is x to the power of x times the natural logarithm of x plus 1. And this would be this equation differentiated. Okay, next example, we have one that's a bit more complex. So we have y equals e to x times the square root of x squared plus 1 over x squared plus 2 cubed, and we want to differentiate this. So we'll start by taking the natural logarithm of both sides. So we've got the natural logarithm of y is equal to natural logarithm of e to the x times the square root of x squared plus 1 over x squared plus 2 cubed. We're then going to break it apart with log laws. So we've got natural logarithm of y is equal to natural logarithm of e to the x plus a natural logarithm of the square root of x squared plus 1 minus the natural logarithm of x squared plus 2 cubed. So now we'll take the derivatives of both sides. So we've got d dx of our natural logarithm of y is equal to d dx of our natural logarithm of e to the x plus our natural logarithm of the square root of x squared plus 1 minus our natural logarithm of x squared plus 2 cubed. So our derivative of this would just be 1 over y times y prime equals our derivative of the natural logarithm of x, which we can actually move this to this side, and we can simplify this, which we probably should have done up here, because natural logarithm of e is just 1, so we just have derivative of x, so that's just going to be 1, plus our derivative of this, which would be 1 over the square root of x squared plus 1 times d dx of the square root of x squared plus 1 minus 1 over x squared plus 2 cubed times d dx of x squared plus 2 cubed. So we've got y prime over y equals 1 plus 1 over the square root of x squared plus 1 times the derivative of square root of x squared plus 1, which would be 1 over 2 times the root of x squared plus 1 times d dx of x squared plus 1 minus 1 over x squared plus 2 cubed times 3 times x squared plus 2 squared times d dx of x squared plus 2. So I've got y prime over y equals 1 plus 1 over 2 times x squared plus 1 times 2x minus 3 times x squared plus 2 squared over x squared plus 2 cubed times d dx of 2x. So that gives us y prime over y equals 1 plus, moving the 2x over here, we can cancel the 2 out. So we've got x over x squared plus 1 minus, we can cancel out all of this with most of this one. And then derivative of 2x is 2, so minus 6 over x squared plus 2. So we have y prime equals y times 1 plus x over x squared plus 1 minus 6 over x squared plus 2. And then we'll substitute our equation for y in. So we've got y prime is equal to e to the x times the square root of x squared plus 1 over x squared plus 2 cubed times 1 plus x over x squared plus 1 minus 6 over x squared plus 2. And that's what our derivative is.